Problem set number 6. What is fluid? Fluid is a substance that has no fixed shape and yields easily to external pressure, a gas or especially a liquid. Example 4.1. What force must a dam withstand? Problem. Consider the pressure and force acting on a dam retaining a reservoir of water. Suppose the dam is 500-meter wide and the water is 80.0 meter deep at the dam, as illustrated below. So, A. What is the average pressure on a dam due to the water? B. Calculate the external against calculate the force exerted against the dam. The average pressure density due to the weight of the water is the pressure at the average depth height of 40.0 meters. Since pressure increases linearly with depth, the force exerted on a dam by the water is the average pressure times the area of contract. F is equal to P area, density area. So A. The average pressure due to the weight of the fluid is density is equal to height page gravity. So we have the height for it. Substitute the values 40.0 meter times 10 cube kilogram per meter cube. Times 9.8 meter per second squared the gravity. So x equal to 3.92 times 10 to the fifth power n per m squared is equal to 392 kPa. B, we have already found the density. So the area of the dam is equal to 80.0 meter times 500 meter is equal to 4.00 times 10 to the fourth meter squared. Force is equal to 9.92 times 10 to the fifth Newton per meter squared times 4.00 times 10 to the fourth meter squared is equal to 1.57 times 10 to the 10th power Newton. Example 14.3. Consider the automobile hydraulic system shown in figure 14.18. Suppose a force of 100 Newton is applied to the brake pedal, which acts on the pedal cycling, acting as a master cylinder through a lever. A force of 100 Newton is exerted on the pedal cylinder. Pressure created in the pedal cylinder is transmitted to the four wheel cylinders. The pedal cylinder has a diameter of 0.500 centimeter, and each wheel cylinder has a diameter of 2.50 centimeter. Calculate the magnitude of the force F sub 2 created F sub F sub 2 created at each of the wheel cylinders. We have the givens. So strategy, we are given the force F sub 1 applied to the pedal cylinder. The cross-section area A sub 1 and A sub 2 can be calculated from their given diameters. Then we can use the following relationship to find the force, or the F sub 2. So we have this formula. Solution, F sub 2 is equal to A area sub 2 and A sub 1. So times F sub 1 is equal to pi r squared sub 2 over pi r squared sub 1 times F sub 1. 0.25 centimeter squared over 0.250 centimeter squared times 500 Newton is equal to 1.25 times 10 to the fourth Newton. Example 14.5. A nozzle with a diameter of 0.500 centimeter is attached to a garden hose with a radius of 0.900 centimeter. The flow rate through the hose on the nozzle is 0.500 liter per second. Calculate the speed of the water A in the hose and B in the nozzle. So A, here We solve the flow rate equation for speed and use pi r squared sub 1 for the cross-section area of the hose, obtaining the V is equal to Q over area is equal to Q over pi r squared sub 1. So, with the value formula V is equal to, substitute the values, 0.500 liters times 10 to the negative 3 power m cube per liter over 3.14 the pi times 9.900 times 10 the power of negative 3 m parenthesis squared is equal to 9.96 meter per seconds. B. We could repeat this calculation to find the speed in nozzle for the V sub 2, but we use the equation of continuity to give somewhat different insight the equation states. So A sub 1. Solving for V sub 2 and substituting pi r squared for the cross section area. So V sub 2 is equal to A sub 1 over A sub 2 times B sub 1 is equal to pi r squared sub 1 over pi r squared sub 2 times B sub 1 is equal to r squared sub 1 over r squared sub 2 V sub 1. So we the givens, substitute the givens, so substitute the value rather. V sub 2 is equal to 0.900 centimeter parenthesis squared over 0.250 centimeter parenthesis squared times 1.96 meter per second. We get the answer in B 25.5 meter per second. Example 14.7. A fire hoses used in a major construction fires have an inside diameter of 6.40 centimeter. Suppose such a hose carries a flow of 40.0 liter per second, starting at the gauge pressure of 1.62 times 10 to the power of 6 Newton per meter squared. The hose rises up 10.0 meter along a ladder to a nozzle having an inside diameter of 3.00 centimeter. What is the pressure in the nozzle? Solution. We have the givens. So solution P sub 1 plus 1 half density V squared sub 1 plus density gravity times height sub 1 is equal to E sub 2 plus 1 half density times velocity squared sub 2 plus density times gravity times height sub 2 V sub 1. So V sub 1 is equal to Q over area sub 1 is equal to 40.0 times 10 to the negative 3 power meter cube per seconds over pi times 3.20 times 10 to the negative 2 power meter parenthesis squared is equal to 12.4 meter per seconds. Similarly, just by using the formula, we get the V sub 2 is equal to 56.6 meter per second. So, yung P sub 2 is equal to P sub 1 plus 1 half times density times V squared sub 1 minus V squared sub 2 minus density gravity times height sub 2. So, substituting 1.62 times 10 to the 6th power n per meter squared plus 1 half times 1,000 rather 1,000 kilogram per meter cube bracket 12.4 meter per second parenthesis squared minus 56.6 meter per second parenthesis squared minus close bracket, so minus 1,000 kilogram per meter cube times 9.80 meter per second squared times 10.0 m meters. So, ang answer na 0. Significance. This value is gauge pressure since the initial pressure was given as a gauge pressure. Thus, the nozzle pressure equals atmosphere pressure as it must, but the water exists into the atmosphere without changes in its condition.